Okay, so for the first problem, it asks you what, and this is problem 3 on the test. The first problem asks you what is the net magnetic field at location A, which is right there. And so you're given a wire, where you're given like 4 wires, and you see that the wire on the top and the bottom are both flowing to the right, and they both have the same magnitude. And then you see that the wire on the left is flowing out of the page, and it has a current of 2I, and then the one on the right is flowing out of the page, and it has a current of 3I. So in order to determine the net magnetic field at A, you realize that like if you use your pencil and you put your thumb in the direction of the current, you just curl your fingers around that, and so then you see that on top of the wire, the magnetic field is flowing out of the page, like closest to you. So you know on top of the wire, of the top wire, the magnetic field is flowing out of the page, and then under the wire, so by A, I'll let you see. So by A, it's flowing into the page. And so then it's the same thing on the bottom wire. So you have both of them. So the two of the wire on the top and the wire on the bottom are canceling each other out. So then the net, since A is closest to the 2I wire, you see that the net magnetic field has to be flowing in the negative Y direction. And then the same thing for C, which is part C of that question. It's asking what the net magnetic field is at C. And since you know that the top and the bottom wire are going to cancel each other out, and since C is closest to the 3I wire, you'll notice that it's also pointing, since the 3I is going into the page, and when you curl your fingers again into the page, you'll see that it's going up and then down. So closest to C, it's still going in the negative Y direction. And so then for B, it's asking what the net magnetic field is there, and that's B right here. And so in the middle, you have the two wires are acting constructively, so they're both going to, the greatest net magnetic field is going to be in the positive Y direction. The top and the bottom are going to interact a little bit, but the net is going to be in the positive Y direction. Sorry, you probably can't see that very well. And then for part D of the question, it says that on the x-axis, there's a location D, and I'm just going to assume it's on to the left of A, and it says at some location D, the net magnetic field is 0. So if you consider the 2I wire to be the origin, you can see my work. So since you're saying this is the origin, it's going to be some distance to the left of A. You know that since from part A, we determined that the net magnetic field is going to be in the negative Y direction. So I just called that the negative, so that was in the negative Y hat direction, and that's going to be a distance D from this origin. And then the 3I wire, is, since you're looking from closest to the like to the left of this wire, it's going in the positive Y direction. So then that's going to be a 3I positive Y hat direction, and the distance from this wire to some location D is going to be 2S. They tell you that the distance between the 2I wire and the 3I wire is 2S. So it's going to be 2S plus D. And so the net magnetic field, you're just going to add the 2I wire plus the 3I wire, and that's going to be 0. And so then you can just solve it, solve the equation, the system of equations, and you end up, you can look at my work, but you end up getting to D equals 4S. Now I did this trying to go to the right, and I got a negative number, so that didn't work. But if you do it to the left, then that should work. Anyways, good luck.